So this question tells us that y grams of a cookie can be modeled by a normal distribution. 12% of the cookies have a mass less than 40 grams, and 75% of the cookies have masses less than 45 grams. And this question wants us to find the mass, find the mean and the standard deviation of y. Okay, so let's start writing our probabilities out. So the probability of the mass of the cookie y being less than 40 is 0.12, because 12% is 0.12, and the probability that the mass of the cookies is greater than 45 is 0.75. Okay, and from this we want to find the mean and the standard deviation of y. For this, we're going to have to find out two separate z-scores, and we're going to have to solve for our standard deviation and our mean using simultaneous equations. Now, our equation to find our z-score, if you remember correctly, is x being our variable. For us, that's y, but I'll just keep it like this. Minus mu, which is the mean, divided by the standard deviation equals z. Okay, so specifically for this probability over here, because our z-score, when calculating it, it's focused on the left tail, so we're actually going to have to write it out as the probability that y is less than 45 is 0.25. And that's how it works in our calculator. Of course this makes sense, because of course it's just 1 minus 0.75. Now let's put our values into our equation. So we'll start with the first one, 40 minus our mean divided by our standard deviation equals z. And now we'll calculate z using the inverse normal function on your calculator. And if you have the Casio 991EX, just go to the menu, then go to number 7 for distribution, and then go to 3, which is for the inverse normal, and your area is going to be 0.12. Your standard deviation is going to be 1, and your mean is going to be 0. And this will find our value for z, which is minus 1.175. So I can just write that 40 minus u over our standard deviation equals minus 1.175. Now let's rearrange the equation. We can write that as 40 equals minus 1.175 lots of our standard deviation, and then we just add the mean on. Okay, that's one equation. Now let's consider this one. That's going to be 45 minus our mean over our standard deviation equals our z value. Now I'll just put that into the calculator now. Our area is 0.25, and we have the same standard deviation and mean, because the standard deviation and mean for the standard normal distribution is 0 for the mean and 1 for the standard deviation. And that gives us an answer of minus 0.674. It is 0.67448, but I'm just going to round it to 3 decimal places. And now if I rearrange it, I can just rewrite that as 45 equals minus 0.674 lots of our standard deviation plus mu for our mean. Okay, now we've got two simultaneous equations containing our standard deviation and our mean. So now we can just solve this. I'm just going to solve it on my calculator. You can solve it manually, of course. Okay, so from this I get a standard deviation of 9.98 grams and a mean of 51.73 grams. Okay, and that's our answer for this question. Just as an added benefit, let's try and visualize this normal distribution curve and see where all the values are coming from. So remember, it's a bell-shaped curve, and our mean is going to be 51.73, and 50% of the data is in front and behind it, above and below it. I'll just write x in grams over here. And our standard deviation is 9.98 grams, so over here at our point of inflection, it will just be 51.73 added onto plus 9.98, and that will contain, if you take both of them into consideration, 68% of the data. But if we just go back to the question, if we just go up, it said that 12% of the cookies have a mass less than 40 grams. So if like 40 is over here, 12% of them have a mass less than that. So we'll just write, this is 40 grams. 12% have a mass of them have a mass less than that 40 grams. And 75% of the cookies have a mass greater than 45 grams. Yeah, we'll write 45 grams over here. And then 75% of them will have a mass greater than that. Okay, I hope that made sense. Let me know if you have any questions in the comments section down below.